to go through the final 8-9 questions of the higher mock paper. I'm going to go through my thought processes behind each question and also hopefully give you an insight into how I as a teacher would answer these questions in order to obtain all the method marks as well. So for the first question, we're looking at a surd, and it's asking us to simplify the square root of 200. Now, the most common method to do this is to just write down all of the factors of 200. Well, it's 1 and 200, 2 and 100, and I could carry on, but I'm just going to stop there. Just straight away, I've noticed that I've got the value 100, and what I like about that is the fact that it's a square number. So I could write root 200 as root 2 multiplied by root 100, because the product of 2 and 100 is 200, and I know that root 100 simplifies down to 10. So therefore my answer is going to be 10 root 2. The next thing that I can look at is 8 to the power of a third. If I've got to the power of a third, that means 3 of these multiplied by each other, so 8 to the third times 8 to the third times 8 to the third, would be equal to 8 to the 1 if I add the exponents. So therefore I am looking for the cube root of 8. So I'm looking for what value, when I multiply by itself and itself again, would give me 8. And looking through our list of cube numbers, we should hopefully get that value to be equal to 2, because 2 times 2 times 2 is 8. Moving on to question 12, we're looking at function machines. Here I've got a function machine A, which when I have an input of x, and I multiply it by 3 and subtract 2, I get an output of y. And I also have a function machine of B, which is when I input x, and I add 7 and times 2, I get an output of y. Before I even look at the question, I'm just going to have a think about the inverses. So if I was going in the other direction, what would I be doing? Well, instead of taking away 2, I would add 2. And instead of timesing by 3, I would divide 3. So without looking at the question, this is the first thing I would do every time, because it will just help me clear my thoughts if I do have to know a question on the inverse. So, question A. Find an algebraic expression for the output of the inverse of function A when the input is x. So the inverse function is going to be looking backwards, so this is why I do this thing in red. And if my input is x, I will be adding 2 and then dividing by 3. So at x, I add 2 and then I divide by 3. It asks me to write an expression, so therefore I don't need it to be equal to anything. I don't need to say equals whatever the output would be. I could just leave it as this, as x plus 2 all over 3. Looking at part C, here is a composite function of C, such that the function of C of x goes through function A, then goes through function B, and my output is z. Find the value of x when z equals 4x. So I'm just going to do some working out up here. I'm going to change my pen to be black so that you can distinguish it from part A. And looking at this, I'm going to try and combine both of these functions to start off with. So I've got x, and I've multiplied by 3, so I've got 3x. Then I've subtracted 2, and that's the end of my first function, so I'd move on to function B. I plus 7 to this, and then I multiply by 2. Now I'm going to put everything in a bracket, because everything is multiplied by 2. So this thing here that I've just looked at, this 2 lots of 3x take away 2 plus 7, is actually my whole function from x to z. So it was 2 lots of 3x take away 2 plus 7, I hope. Let me just check. Okay, and I know that if I have the input of x, my output would be z, but in this scenario, that is 4x. So, just doing a little bit of manipulation of algebra here. The first thing I'm going to do to make it easier for myself is divide by 2, so I don't have to worry about the bracket, and also sort out this take away 2 plus 7. So, I'm going to get rid of this 2 by dividing across, and sort out this take away 2 plus 7. So that would leave me with 3x plus 5 is going to give me 4x divided by 2, which is 2x. From here, I want to take away 5, so that would give me 3x equals 2x take away 5, and then take away 2x gives me x equals the negative 5. So I'm just going to show my workings out in red, just so that you can follow. So going down here, I divided by 2. Going down to the next line, I took away 5. And finally, on the last line, I took away 2x. That left me with my answer of x equals negative 5. And I'm just going to check that. I know that if I start off with negative 5, my final answer wants to be negative 20, because 4 times negative 5 is negative 20. Negative 5 times 3 is negative 15. Take away 2 gives me negative 17. Add 7 gives me negative 10. Multiplied by 2 gives me negative 20. So therefore, I can self-check that this would be correct. Question 13 is looking at a graph, and it says Shirley is asked to sketch a graph of y equals 5 to the power of x for all values of x greater than or equal to 0. She produces the following. The graph has 2 errors. How could they be corrected? The first thing to notice is that the graph that Shirley is trying to sketch is an exponential graph. Now, we know that any value to the power of 0 would equal 1. So therefore, first of all, Shirley's graph should go through at 1. The next thing we know about an exponential is they follow sort of an exponential curve. So the graph should start off shallow and then slowly peak up and get really steep. So, how could this be corrected? It would need to have an intercept of the y-axis, which would be at 0, 1, and then the curve would actually need to be a curve rather than a linear line. An exponential curve would be needed. And I might just put it down, but it would need to be an increasing curve as well. So rather than something that's sloping down, it would need to be an increasing curve. Okay. Question 14. In the diagram AB is parallel to CD. AED and BEC are straight lines. Prove that the triangle ABE is similar to the triangle CDE. Okay, so I've got parallel lines, and when I think about parallel lines, the main thing I'm thinking about is angles. So, in order to note this as a proof that they're going to be similar, I'm going to be trying to look at getting all the angles to be the same in some way. So to start off with, I'm going to focus on this angle here, and this angle here, and we should see that because they are vertically opposite, they would be equal. So I'm going to denote it as angle CED must be equal to angle AEB, and I'm going to say as vertically opposite. Okay, that's the first one done. The next thing I'm going to be focusing on is looking at my angles on my parallel lines. So I've got an angle here, which looks like it's pointing this way, and I have an angle at B, which is pointing in the opposite direction. You could say that they're pointing in alternate ways. And we know that alternate angles on a parallel line are equal, so therefore angle at C and the angle at B must be equal. So angle ECD is equal to angle EBA as alternate angles. And finally, I could use that same idea for the angle at A. I'm just going to indicate with triple lines that they're going to be equal. So angle EAB is going to be equal to angle EDC. And again, for the same reason, because they are alternate. I'll just finish this with a closing statement that as all three angles are equal, therefore the triangles must be similar. And that'd be a nice way to finish off the question. Question 15 is about a sector of a circle. It says OAB is a sector of a circle centre at O. OA is 6 centimetres and AX is perpendicular to OB. So they've given me some form of right angle triangle. The area of a sector OAB is equal to 6 pi in centimetres squared. Show that AX is equal to 3 root 3. So, I don't know much about this angle yet. And I know that I want to show that a to the x is something. So let's call this length y. And I want to know what that is. So, the area of a sector OAB is 6 pi. Well, I'm going to start off with that because I know a formula for the area of a sector. The area of a sector is the fraction of the circle that I have, which is theta over 360, multiplied by pi, multiplied by my radius squared. Well, my radius in this case is 6, indicated here and indicated in the question. So therefore, my sector of the circle, the area, is going to be multiplied by 6 squared, and I know that is equal to 6 pi. So looking at this, I've got theta over 360 times by pi times by 36 is equal to 6 pi. And what I'm going to do just quickly is I notice that I have a pi symbol on both sides. I've got a pi here and a pi here, so therefore they're just going to cancel out nicely to start off with, so I don't have to worry about any sort of multiplying by pi, which will be tricky without a calculator. The next thing to note is that 360 and 36, if I do that division, 36 divided by 360, that's going to leave me with 1 over 10. So therefore on this left hand side, I end up with just theta over 10, and that's going to be equal to 6. So therefore rearranging, I get theta equals 60. I'm just going to put that into my actual diagram now, that this is equal to 60. And then if we look at what we actually have now, we've got a right angled triangle. If I label it clearly for you, we have an opposite, we have a hypotenuse and an adjacent, but we also have this angle now of 60 degrees. So looking at this, I'm going to think about what trigonometric ratio links the opposite and hypotenuse, and that would be the sine. So I would know that sine theta is opposite over hypotenuse. So therefore my sine of 60 is going to be equal to my y value, which I want to find, over 6. Looking at my exact trig values, sine of 60, if I think about my equilateral triangle of a length 2, 1, root 3, my 60 degree angle would be here, so the sine would be equal to root 3 over 2. So I know sine 60 is equal to root 3 divided by 2. So therefore, I can multiply across by 6. 6 lots of sine 60 equals y. And the issue is I didn't know what this sine 60 was before, but now I know it's root 3 over 2. So therefore I get 6 lots of root 3 over 2 equals y. And therefore y, 6 divided by 2 is 3. Is equal to 3 root 3, as required. If you wanted to be precise, you could replace the y with a to x and say that ax equals 3 root 3. Or you could have said let y equal ax. Question 16 is to do with a circumference and looking at a circle. Whenever we're given 4 points on the circumference of a circle, we should be screaming out for a cyclic quadrilateral. Because that's the only circle theorem we know which indicates 4 points on the circumference of a circle. Angle BAD equals 112 and angle DCO is equal to 33. The first question is asking us to show that angle Y, which is this one, is going to be equal to 35. So, I'm going to first of all note on that I've got some isosceles triangle here because they're both radii. And looking at this, angle DAB plus my angle BCD is going to be equal to 180 as cyclic. Because it's a cyclic quadrilateral, my opposite angles are going to sum to 180. So 112 is angle DAB plus 33 plus some angle OCB is going to be equal to 180. So therefore, my angle OCB is equal to 35. Because 180 take away 145 is 35. I might just note that down actually. 180 take away 145 is 35. That helps me to work out what this angle is. But in order to indicate what y is, I first of all need to state that angle OCB is equal to angle y. And the reason for that is because base angles in an isosceles are equal. As base angles in isosceles are equal. A lot of writing. So therefore, y must be equal to 35. Work out angle z, give reasons for your answer. So I'm going to look where angle z is. Angle z is here. Looking at this then, I've got a point at the circumference. If this is 35 and this is 35, my angle here I could work out. These sum to 70, so this is 110. And I could work out z by the angle at the circumference is half that at the angle at the centre, so z must be equal to 55. But how I'm going to reason that is angle z is 55 because, and I'm going to say the angle at the centre is twice that of the angle subtended at the circumference. So, moving on to question 17, this is completing the square. This should have been attempted by the majority of the students because even though it's a higher level topic, the process that we use is very common and it's also quite easy to pick up the marks. X squared plus 8x plus 3 in the form of x plus a squared minus b. So to do this, I'm first of all going to get my square. The only thing that I know which will give me an expansion of x squared plus 8x is going to be x plus 4. So when I think about x plus 4 squared, I end up with x squared plus 8x, which is what I want, but I also end up with this plus 16. So what I need to do is take away that 16 to get it back to what I wanted, and then I have to plus 3. That leaves me with x plus 4 squared minus 16 plus 3 is going to be negative 13. Sketch the graph of y equals x squared plus 8x plus 3, showing clearly any turning points and the y-intercept. Well, the y-intercept is where my original graph is at x equals 0. So, if I say at x equals 0, y is going to be equal to, well, it would be 3. I know I'm going to have a point that crosses at 3. The turning point, well, this is going to be when my curve is at its lowest point, as it's a minimum, because x squared is positive. Well, the lowest point is when my squared value is 0. So x plus 4 must be equal to 0. So therefore x must be equal to negative 4. When that's the case, y is equal to negative 13. So I'm going to have a point negative 4, negative 13. Let's put it here. And then all I do now is just plot my curve. It's going to be a parabola. And just make sure it goes through your points. Looking at question 18. 21 people travelled to a meeting. 12 used a train, 6 used a car, 7 did not use a train or a car, some used a train or a car. When I'm looking at information, I can look at these two first lines and I can deal with those in multiple different ways, maybe a two-way table. However, this third line, where it says 7 did not use a train or a car and some used both, that should be immediately saying to you that we are going to be looking at a Venn diagram because we have some information which is for both, which would be in the centre, and some information which is for none, which would be on the outside. So now I set up my Venn diagram with a train and a car. I'm going to look at how much information I have. 12 used a train, 6 used a car, 7 did not use a train or a car. So my 7 that did not must go on the outside. There's nowhere else they can go. So how many people do I have left over? Is 21 take away 7, which is 14. 12 used a train and 6 used a car. If I add them together, that gives me 18. And here we have a bit of a tricky situation, because even though I have 18 pieces of information, I only have 14 slots it can go in. So therefore, some values have been counted twice, and those values which have been counted twice must be in the centre. So there are 4 people who have done both a train and a car. So 6 used a car in total, 4 have used it here, so therefore 2 have left over in the car, and 12 used a train in total, 4 are here, so there are only 8. 2 people are chosen at random from those who used a train. Find the probability that both these people also used a car. So those people who used a train are 12, so therefore my people being chosen, my first person is going to be out of 12. Find the probability that this person also used a car. Only 4 of the 12 people used a car, so therefore it must be 4 out of 12. The next time this happens, there's only 11 people left, and now we've decreased our value of 4 by 1, so therefore it's 3. So we get 12 over 132, which is 1 over 11. And that would be my final probability for question 18. And finally, the last question on the paper was quite a tricky question. It was to do with this cubic graph of y equals x cubed minus x squared minus 2, and use the graph to solve that x squared minus x minus 2 and give you answer to 1 decimal place. Well, if we're solving it, in this scenario it's equal to 0, so therefore I'm going to zoom in to the point where it's equal to 0 and just read off that value. So on here it's at 1.5, I don't want that up, and it's going to be at about 1.6 here, 1.7. So solving this would give me an answer of x equals 1.7. So x equals 1.7, and that's just by looking at the graph and indicating that it's at this point here. The next part says the equation x cubed minus x squared plus 5x minus 6 can be solved by finding the intersection of the graph of the one we've just looked at and a separate line. If I was given a cubic and a linear, the way we would solve this would be we'd set them equal to each other and then rearrange to make it equal to 0. So that's exactly what I'm going to do. I'm going to set x cubed subtract x squared subtract 2 equal to ax plus b, and I know that I need to get that equal to 0, so therefore it's x cubed subtract x squared. I'm going to take away ax, take away b, take away 2, equals 0. And from here, I'm just going to compare coefficients. Negative a is going to have to equal to 5, and negative b take away 2 is got to be equal to negative 6. So just writing these out as separate statements, I'm going to have negative a, I don't want that as a highlighter, I'm going to have negative a is going to be equal to 5, so therefore a must be equal to negative 5, and then negative b take away 2 is equal to negative 6, so therefore negative b is equal to negative 4, so b must be equal to positive 4. So I found out my values of a and b. Let me just write them in here. So a is negative 5 and b is positive 4. Hence, use the graph to solve the equation to 1 decimal place. So what I need to do is plot this line. Now, looking at y equals ax plus b, I've got the line of y equals negative 5x plus 4. Y equals negative 5x plus 4. I know that's going to go through at 4, and it's going to have a gradient of negative 5, so therefore at 1, it's going to go through at negative 1, which is here. So just drawing my straight line, just needs to go from this point through here, and I'm just going to zoom in and look at this coordinate here, and what exactly does it want me to know? It wants me to give your answer to 1 decimal place, so I just need the x coordinate, and the x coordinate would be it'd be positive 1 point, it's about 1516, so it's about 1.16. Hopefully that will be more obvious on your paper where you can zoom in and see it, but that would be the end of this mock paper. If you have any questions, please let me know, and if there's anything I could do to help you, either in lessons or after school, I'll be more than welcome to. Thank you for watching, and I'll see you in the next one.